Dear students, today we are going to see the correlation and regression using SPSS. So for this we have taken the example from the book Marketing Research Text and Cases by Nargurkar. So in this we have the data as we are seeing it here in the data view. We have sales. So if you see the variable view, you will see that the sales in rupees in lakhs, the potential which is market potential in rupees in lakhs. Then we have dealers, that is the number of dealers. People means number of sales people. Competitor activity level, number of service people, and then number of existing customers. Sales in rupees lakhs is the dependent variable, and the other variables are the independent variables. So first we are going to run the correlation analysis. So for that we will do analyze, we'll go to correlate, and we will use bivariate. So all the variables will be initially on this side. So we will just take them using the shift key on the other side, and correlation coefficient we will use Pearson, and we will also flag the significant correlations in case we want it. So we will click on the flag the significant correlations. So we'll say OK, and we will get this output. Because the output is not really very clear, we can just copy it to a Word file. So you can just click here and say copy paste, which I have already done. So let me open the Word file. So if you see here in the Word file, I have already taken. Now, because we have in the output all the correlations, what we are interested is the correlation of the dependent variable with the independent variables. So we are just taking the first row of the table. The other rows are not really required. So we have just copied that first row here, and we have just we can just see this. So how to analyze this, I have already mentioned it here. So based on the p values, so these are the second significance to tell are the p values, except the variable competitor activity level, which is 0.872. All other variables are having less than 0.05. So which is our significant level of 5% or confidence level of 95%. So since all are having less than 0.05, we say that these variables have significant correlations with sales in rupees in lakhs. Only competitor activity level, the correlation is not significant, right? Once we know that the variables are significant correlations, now we go to the first row where Pearson correlation coefficients are given, and we see that the values of significant correlations are also very strong because they are close to 1. Anything more than point say 9, we can say it is very strong. More than zero point 0.7, we can say it is a strong correlation. So market potential is strongly correlated, number of dealers is strongly correlated, number of sales people is strongly correlated, whereas number of service people and number of existing customers are weak, are not fully very strongly, but they are also strongly correlated because they are more than zero point 0.7. Although the competitor activity correlation is not significant here when we are checking it individually, but we do not drop it, we are not going to drop it from the regression analysis. because sometimes such variables can play a major role in regression analysis along with the other variables, right? So this is about the correlation. Now we go for the regression analysis. So we go for analyze, regression, and then linear regression. uh, the sales will be in the dependent variable and all others will be in the independent variables. So we use, first we go for enter method where all the variables will be considered in one go, and we go for OK. And here again, because the model summary, ANOVA table and coefficients, these are the three tables which we are going to copy to our Word doc. So I have already done that here. So if you see the enter method, the first table is model summary table, which shows the R square value of 0.977, right? R adjusted is 0.960. ANOVA is showing significant, which means the model is significant. And then to write the model, we are going to use from the coefficients table, we are going to use the unstandardized coefficients B value. So B value are the coefficients. So using this, we will write our model. So here I have already mentioned that first we will look at the ANOVA table and we see that the value of P value is less than 0.05, and hence our model which enter method has given us is significant. Now how to write the model? We are going to use these variables, coefficients of this, and these are the variables. So we will multiply them with each other and then write our model. So our model will look like this. Sales is minus 0.3.173, which is our constant, and then for with every variable we will multiply their coefficients. So this is the model which we finally got. Now in case a new territory sales needs, we need to estimate, we need to take this model and the given information for the new territory, we will put it in this equation, and then we can get an estimate of the new territory's sales. This is how we can use this model for our advantage. The R square value for this model is given in the model summary, which is also very good, right? So R square 0.977, that means the 97% of the variance of the dependent variable is getting explained by this particular model. Now there are two other methods. One is forward method and other is backward method. So when we want to do forward method for regression, we will just change this here. We will use forward here and then say OK. And in the second time we go for backward and we say OK. When we run this, for example, forward method, you get the forward methods tables, right? Then when we run the backward method, you will get those tables, which I have copied. The important tables I have copied on the Word doc for better visibility. So now for forward method, our two tables are important. One is the model summary and the coefficients table. The ANOVA table is showing all that the models are significant. So how the forward method works is that it takes the most significant variable and first forms the equation. So the first equation has happened here, and then it will add the next significant variable. Here market potential is the next significant variable. It is added, and if the R square improves, that particular variable is retained. If not, it is dropped. So this is the process it follows till you keep on improving your R square value. So here the process is stopping after two iterations and our R square value is coming 0.96, and this second table, the second row of the table gives you the model with the unstandardized coefficients. So this is the model sales is minus 10.616 plus 1.424 into number of salespeople and 0.243 plus into market potential. When we use backward method, it starts with all the variables and it keeps on dropping the non-significant variable. Every one step, one variable is dropped till you get a good R square. So here if you see here, the fourth step is we are getting 0.964. The R square has started dropping, so we have stopped here. So fourth iteration gives us the our model. So this is the fourth table. Again, we will use the unstandard coefficients to write our model. So this is how the backward method model looks like. And the R square value is 0.971. Now, what is the advantage of forward and backward methods? That we don't have to wait for all the variables availability for the estimation of the sales. So in the forward method, just with two number of independent variables, we can estimate the dependent variable. In backward method, we require three independent variables information for the estimation. So this is how we perform correlation and regression. Thank you.